I've got this Samsung 46-inch LED TV. This is a smart LED TV. It's a UE46ES8000. It's quite a nice TV. It's LED, so it's not one I'd keep myself, but it's one of the top of the line about 2.5–3 years ago. The fault this set has is it's basically clicking on and off, rebooting all the time, with random patterns on the screen. I had this one on my YouTube channel a while ago, and what I found was it appeared to be this connector here may have had some kind of corrosion on it. I wasn't certain, but it looked like some of the pins are a little corroded, and this is a known issue with this model. Samsung has a service bulletin out for it. So what I did is I just took that connector out on both ends and I cleaned it with isopropyl alcohol, and I thought I'd fixed it because I ran the set for about 2 odd weeks, just on and off. And it didn't have a single problem after that. So I gave it back to my dad, and then he turns it on for about an hour, and then it fails on him. So I was a bit at loss of words for exactly what was causing this. But it is exactly the same fault, so obviously I hadn't fixed it. Just goes to show, eh? It might have been the fact it was moved all the way from London in a bumpy car. It caused the connector to move into a position where it's not making good contact anymore. Anyway, what I'm going to do is basically go through a troubleshooting process on this, just to see if this actually is the problem, because I'm not certain yet if I did discover the problem or it was just pot luck that I fixed it. So I'm going to use my multimeter for this, and the important thing here is, oh, this frame is not magnetic. Well, that's useful. You can see the multimeter down there. Yep. The important thing here is I'm going to measure the 5 volt from the power supply on this end and then the 5 volt on this end, and we want to measure basically the voltage drop across the connector. This includes the connector assembly here, where this connector mates into this PCB connector, the wires, and the connector at the other end as well. So I'm going to measure from one pin on here to one pin on there, and sort of want to get a kind of proxy measurement of how much the connector is dropping. Now, normally in operation I would expect maybe 50 millivolts of drop across this whole assembly. So we'll see what I actually measure. I have a suspicion it's going to be much larger, and this is what's causing the actual problem. The TV is actually working fine right now. It's sometimes inconvenient when TVs work, they don't. So you see on the other end, on the power supply end, got 5.26. And on the main board end, which is on this pin here, we have, I hope that's visible on the camera, about 4.9. So that is a drop of, roughly speaking, 300 millivolts. That's quite high. Given the board shouldn't be drawing much more than about an amp over that rail. I mean, it is rated at a total of 0.58 amps on the standby rail and 5 amps on the main rail. So it's actually quite high, 5 amp rating. But I'm now going to try and activate some of the functions of the TV, such as the webcam and maybe the smart menu, which might make it draw more power. Now the smart menu is on the screen, so it might be processing that. I don't know how these smart TVs operate. Now I've got 4.87. Okay, it's a little lower. Let's try something more. Let's try putting the camera on the screen, because this is one of those TVs with a silly web camera. Camera selected. So now it's actually processing an image now. Showing an image on the screen, using more processing power, obviously. Now I've got 4. Oh, see, it's varying there. I've got 4.80, 4.87, bit all over the shop, really. And that kind of variation is not good. That kind of variation causes issues. What I'm now going to do is I'm going to hook up my oscilloscope to this system, and I want to measure how much the voltage on the end is varying, and see if we can pick out any kind of anomalous issues. So I hope you can see the scope trace there. Actually, I'm just going to zoom it in a little more, so we can see the variations a little closer. What I'm going to do now is going to activate various functions of the remote. I might have to do this from the top. I think the IR sensor on this TV is at the top, yeah. So I've now activated the smart menu. You might be able to see these little drops. So it's still loading this smart menu. God, these smart TVs are slow. Never understand this. Or I don't know why this. It's just so slow to load everything. Starting up. I'm a bit of a smart TV cynic. You might have gathered. Okay. Now it's doing that. Just going to see if I can activate the webcam. It's our benchmark test in this case. Ooh, it's got Facebook, has it? Wow. Because I have to Facebook everything I do in my life. Okay, I don't know if the app is loaded yet. Yeah, it's loaded now. It's showing a webcam image. I'm just going to set the scope now to AC coupling to amplify this noise that we're seeing. So it is well in excess of about 300 millivolt peak to peak. And look at that, that's quite a lot of noise. Now this 2 divisions here is 100 millivolt. But yeah, we can see we've got this lower frequency stuff going on in the signal. It might be hard to see on the camera, but I'll just try and zoom the camera in there. You can see this occasional portion of the waveform is a little lower. And this kind of variation is quite high, but to rule out a possible power supply issue, I do have to check at the power supply end too. So what I've done now is I've put the probe on the power supply end, as you can see there, but I've actually stuck it across the 5 volt capacitor because it's a lot easier to probe there, especially because there's no easy grounding points on this chassis to use as a scope ground. So what you're seeing on the scope now is the ripple measured at the power supply. Just going to go into the same system menu, same kind of smart TV function. Just loading up that smart function. But it's worth noting immediately the ripple on here is considerably different. We've got the conventional switch mode power supply ripple, which if I zoom in will be visible. Basically that set trigger. That kind of triangle ramp you can see there. That's absolutely normal, there's nothing wrong with that, and the extra capacitors on the power supply and the main board will do that quite effectively. But what's most notable here, if we have a look at the low frequency stuff, the longer time base, there is none of that low frequency moving up and down that we saw at the main board end. Couple this with the fact that we're seeing about 0.3, 0.4 volt drop along that connector, and it does indicate that something might be wrong with that connector assembly. Earlier, when this set was actually malfunctioning properly, it was measuring a 4.5 volt error. Sorry, it was measuring 4.5 volts at the mainboard end. Okay, so I've got the set running now, just normally operating, and I've got my thermal camera here. As you can see, I've got the macro lens on it, so the focal length is pretty close. So this is just looking at this connector here, so we can see the normal 13 odd volt pins, and you can see how hot this pin is. It's like about 52 degrees there, that one there. And you can see the heat is actually being conducted quite strongly along the wire. What's most interesting here is how it really is just that pin that's getting hot. If you follow the wire back, you see it's dissipated pretty quickly and there's no major power dissipation issue in the wire. And if we go all the way to the other connector here, we see that it's getting a little warm, but nowhere near as bad as the other end. So this does kind of indicate where the fault is on this set. It's a kind of interesting fault. I've never had one like this happen before, but it's useful. You can use the thermal camera in several other ways as well. That lens off now, so now you can see the larger shot. That's the processor on the main board, and if I can find it on the camera, because I haven't got a visual reference on this image here. You can see the other stuff. That is some of the LVDS driver chips down there, and that's the connector of the power supply. And that's the default focal characteristic of this camera is not very nice. The lens makes it very useful for surface mount. Yeah, you see there's basically no comparison between the two connectors. That one is just really problematic. It's just getting really hot. You see some of the transistors and diodes on the power supply there. So that kind of indicates what the problem probably is on this. What I've decided I'll do is solder a wire from that pin on the power supply, from those two pins, and probably either I'll cut this wire and join up midway, that's the preferred solution, or I'll solder it to the main board. I don't really want to solder it to the main board, because if I do that, then I will be attaching the two boards permanently to each other, and yeah, that'd be awkward if they ever needed to be changed. Anyway, just a interesting fault. Honestly, never had this happen before, so